Hello students. So today I am going to explain to you how to find stationary points and non-stationary points of inflection just in 4 easy steps. Okay. This is in the syllabus of IBAAHL. Okay. So let us start. I took a question and this is part of SL 5.88 testing for maximum and minimum optimization points of inflection, right? The question says find stationary and non-stationary points of inflection of the following function. I took this function because this function includes stationary as well as non-stationary points of inflection, right? So this function is f of x is equal to 1 over 4 x to the power 4 minus x cube. Now, as I said, I will explain to you in 4 easy steps. So step 1 says differentiate the function, right? We will differentiate this function. As you know, the power will go to the left, 4 will come here, and from power we subtract 1. So 4 will become 3, right? Similarly, in the second term, power 3 will come to the left, and from power 3, we subtract 1, so it becomes 2. This is first derivative. After simplifying, it is like that because this 4 and this 4 will cancel. Now, the second derivative, okay? For second derivative, again, the power will go to the left and 1 minus 1 from the power. So this will be 3x square. Similarly, from second term, power will go to the left, 3 times 2, 6, and from power we'll subtract 1, so x only, right? So second derivative is 3x square minus 6x, right? Because for stationary and non-stationary points of inflection, we need to find the second derivative as well, right? Now, why we need that? Because the concavity will be explained from the second derivative only. Now, step 2 says set f dash of x is equal to 0 and find values of x. So I'll take the second derivative, this one equal to 0, 3x square minus 6x equal to 0. I took 3x common factor, so x minus 2. Now from these two factors, x is equal to 0 or x is equal to 2. I got 2 points, okay, from the second derivative by taking second derivative equal to 0. Now, before I proceed, I want to explain to you how to identify maxima, minima, and point of inflection from second derivative. Look here. From second derivative or even without finding derivative, if you know the graph, I have drawn one graph here and let us check or discuss how to find whether the point is a maximum point or minimum point or point of inflection. See, if concavity remains same to the left and to the right of a point, then it is either maximum or minimum point. For example, look at this point. You know that this point A is a maximum point. So see, before point A, it is concave down. After point A, still it is concave down. So concavity is not changing. Therefore, it is a maximum point. Similarly, point B is a minimum point. Look at the left of B, it is concave up. To the right of B, still it is concave up. So concavity is not changing. Therefore, it is minimum point. But if you look at point C, which is in between maxima and minima, look at the concavity. To the left of C, it is concave down. To the right of C, it is concave up. So, about the point C, concavity changes from concave down to concave up. Therefore, this point C is point of inflection. Is that clear to you? So same thing I wrote here. If concavity remains same to the left and to the right of a point, then it is either a maximum or a minimum point. And if concavity changes to the left and to the right of a point, then it is point of inflection. Okay. So if concavity changes, okay, concavity changes, then it is inflection. It is a point of inflection. And if concavity doesn't change, remains same, if concavity remains same, then it is either a maximum or a minimum point. Is that clear? Okay. Let us go to the next part. It is step 3. What is step 3? Test for sign change. Means we will draw the sign diagram. So we have second derivative. We have 2 points of second derivative taking it equal to 0, 0 and 2. Okay. Now on the number line, I will take 0 and 2 according to their position. So 0 is a minimum, is less than 2, therefore it will be to the left. 2 is greater than 0, therefore it will be to the right of 0. Now on the left of 0, we take a point which is less than 0. Let us take -1. Between 0 and 2, let us take 1. To the right of 2, let us take 3. Now this point we will substitute in the second derivative. Okay. So I am putting this point in the second derivative, -1. So here -1, here -1. So I am getting +9 because -3 into -3, +9. So this is a positive point, right? This is a positive point. Then I am putting 1 into the second derivative. So 1 here will give me 3 into 1, 1 minus 2. It will be 3 positive into -1. So it will be -3, which is negative. So f double dash of 1 will be negative to the right of 0. Okay. So it is negative to the right of 0. It was positive to the left of 0, right? And it is negative to the right of 0. Okay. Right. 1 minute. I was erasing this part only. Okay. Now let us see point x is equal to 2. To the left of 2, it is 1. So I have already substituted 1 in the second derivative. It is negative. So here we have negative. And to the right of 2, 3 is there. So we will replace 3 in place of x in the second derivative. So f double dash of 3 is equal to 3 into 3 and second bracket 3 minus 2. So here we are replacing 3, here we are replacing 3, which is here and here. So 3 times 3, 9 into 3 minus 1, 2. 3 minus 2, sorry, 1. So 3 3s are 9, so positive 9. So this point is positive, right? Now look here. If the second derivative is positive, the graph is concave up. If the second derivative is negative, the graph is concave down. And if the second derivative is positive again, the graph is concave up. Okay. I'll explain to you these things from its graph actually. So therefore, sign of f double dash of x changes from positive to negative around x is equal to 0. It changes from positive to negative. Therefore, it is point of inflection, right? It is point of inflection. Okay. And the sign of second derivative changes from negative to positive around x is equal to 2. So between at this point On the left, it is negative. On the right, it is positive. So concavity is changing. I have drawn the concavity also so that you understand. So as the concavity changes around the point x is equal to 2, therefore this is also point of inflection, right? Okay. So I will show you the same thing on the graph also, right? So look at the graph. Here is the graph of the same function, right? This is that function. Its graph is here. So this is the point 0, 0. This is the point 2, negative 4. Now look here. To the left of 0, it is concave up. To the right of 0, it is concave down. Okay. Similarly, here to the left of 2, x is equal to 2, it is concave. Sorry. It is concave down. And to the right of this point 2, it is concave up. So concavity changes at this point as well as at this point. Therefore, both of the points are points of inflection. Now, fourth step, to decide which one is stationary point of inflection and which one is not stationary point of inflection. For that, we classify it from the first derivative. Remember that we have two values of x for point of inflection. Here x is equal to 0, here x is equal to 2. First, I will replace x is equal to 0 in the first derivative. See, now here I am using first derivative. So 0 here, 0 here, okay, will give me 0 into anything is 0. So I am getting 0 here. The first derivative is 0. Therefore, the gradient is 0. And when gradient is 0, this point is stationary point of inflection. When gradient is 0, it is a stationary point of inflection. Then in the first derivative, I will replace 2. When I replace 2 here and 2 here, I'm getting, sorry, 2 here and 2 here, I'm getting 2 square into 2 minus 3, which will be 4 into negative 1, negative 4, which is not equal to 0. Okay, this is not equal to 0. Please remember it, that it is not equal to 0. Okay, so when it is not equal to 0, then the gradient is not 0. And therefore, the point 2 and negative 4, which I have calculated here, their y coordinates, okay, is non-stationary point of inflection. Is that clear to you? It is non-stationary point of inflection. See, if the first derivative is equal to 0, it is a stationary point of inflection. If it is not equal to 0, it is non-stationary point of inflection. I hope you understood all this. So we end the lesson here, right? You can ask me if required any questions, any doubts on my WhatsApp number. You can download the PDF of this lesson from the link given in the description. But for you, I have put some quizzes, some questions for practice quiz. Okay, so that you can try to solve. It has gone further, I think. 1 minute. I'll bring them back there. Where I have kept, I don't remember it. Anyway, it should have been in some other file. Let me check that file where I have kept it, because I had saved it somewhere. Anyway, if I will not find it, I'm going to put it in the file which I have explained to you just now, right? Okay, but I hope you understood the concept, right? Okay then, bye for now.